Experiment number 1C, clampers. Here we are going to see positive clamping, negative clamping. So what is clamping or clamper? Clamper is a electronic circuit that changes the DC level of a signal to the desired level without changing the shape of the applied signal. We can say that the clamper is a circuit which moves the signal either upward or downward to set either a positive peak or negative peak of the signal at the desired level. So it is also called as DC shifter. It is also called as DC shifter. So we'll see that aim of the experiment to design and test the positive and negative clamping circuit for the given reference voltage. Components required are power supply, cathode ray oscilloscope, that is nothing but CRO, signal generator, diode BYN 127, resistors of 10 kilo ohm, and capacitor. So we have to select the capacitor in terms that it will withstand for the long, it should not be discharged. So first we will see the negative clamper. So what is negative clamper in the sense? Here the input will be given from the function generator, that is Vi, and it is connected to the capacitor. Then it is given to the diode. So diode anode is connected to the capacitor and cathode is connected to the reference voltage of 2.3 voltage. That is 3 volt is the reference, but diode cut-in voltage is nothing but we have 0.7. So V reference minus Vd is nothing but V0. So that is nothing but 2.3, and RL is connected here and output is taken here. So during positive half cycle, the diode is in forward bias condition. So both input supply voltage and battery supply voltage are both are in a forward bias condition. So the current flows through the capacitor and charges the capacitor. During negative half cycle, the battery voltage forward biases the diode when the input supply is less than the battery voltage. When the input supply voltage is greater than the battery voltage, in the sense that time the diode is reverse biased by the input supply voltage. So in that output, the output signal is appears the capacitor value, the capacitor signal is appeared in the output. So here now what will happen in the sense the signal is shifted downwards. Okay, so 2.3 will be the reference value that will be shifted. So the whole signal will not be, there is no change in the shape of the signal. So we'll see the design. So to design the clamper circuit to clamp the negative peak of the output voltage at 3 volt. So we have V0 maximum is equal to V reference plus Vd. So V reference we have taken as a 3, and drop voltage drop across the diode is nothing but 0.7. So V0 is equal to, we are getting that 2.3. So V reference is nothing but V0 minus cut-in voltage, that is nothing but 3 minus 0.7 is nothing but 2.3. So given frequency is 1 kilohertz, time period is 1 millisecond. So we have to choose the RC value, time constant, greater than the T, so that tilt in the waveform is negligible, C does not discharge. Let RC is equal to 10 times of T, then T value is 1 milliseconds. So that is nothing but RC is 10 milliseconds. So by using that we can find out the capacitor is 1 microfarad and R is nothing but 10 millisecond divided by 1 microfarad is nothing but 10 kilo ohm. RF is the diode forward resistance and RR is the diode reverse resistance of 100 ohm and 1 mega ohm respectively. So R is equal to 10 kilo ohm and T is equal to 1 millisecond. And next one is a positive clamping. So positive clamping here is nothing but how the function generator input signal is given, that is connected to the capacitor, and the another end of the capacitor is connected to the diode, diode anode, and diode cathode is connected to the biasing circuit, and the resistance is connected parallel to the diode and the output is taken. So here what will happen in the sense, during positive half cycle the battery voltage forward bias is the diode when the input supply voltage is less than the battery voltage. This current will flows to the capacitor and charges the capacitor. When the input voltage is greater than the battery voltage, then diode stops and allowing the current flowing through the diode, and the, because flowing through the load, and the diode becomes the reverse biased. So during negative half cycle the diode is in forward biased by both input supply voltage and battery voltage. So the diode allows the electric current. This current will flows to the capacitor and charges the thing. So here what will happen in this sense, the positive clamping, the output is, the signal is shifted to the upward direction with the reference of 2.3 volt. So here design is to design the clamper circuit to clamp positive peak at 3 volts. So we know that we have V0 is equal to minus V reference plus VD. So from that we have to find out what is V reference. V reference is equal to minus V0 plus VD. So our input voltage is nothing but 3 volts plus 0.7, minus 3 volts plus 0.7 is nothing but minus 2.3 volt. So the frequency is F is equal to 1 kilohertz, T is equal to 1 millisecond. We have to choose the RC value greater than the T so that the capacitor does not discharge during positive half cycle. So RC is equal to 10 times of T, so that is nothing but RC is 10 milliseconds, and assume that C is equal to 1 microfarad. From that we can find out R is equal to 10 millisecond divided by 1 microfarad is nothing but 10 kilo ohm. So what is procedure? So procedure is, first rig up the circuit as per in the circuit diagram, and input sinusoidal signal of 1 kilohertz frequency and amplitude of 8 volt peak to peak is applied from the function generator. So peak amplitude of the input must be greater than the clamping level. Display the output on CRO, compare it with the given waveforms and increase the input further. Note down the output peak is clamped to the desired level. For the same circuit, give the square wave input also and compare with the various waveforms. Make the V reference is equal to 0 and observe the corresponding peak is clamped to plus or minus 0.7, and the result is the clamped waveform at desired level is obtained and clamping circuit is studied.
Last part of the first experiment is clampers. So under that we will be seeing negative clamper and positive clamper. So what is the purpose of the clamper is to clamp the signal to a new DC level. So now initially if you are seeing an input waveform starts at 0 volts, but now I want to clamp this input waveform to some other DC level. That DC level is going to be here. Negative clamper means it is going to be minus 5. That is a negative new DC value is going to be here minus 5.3. So here I am going to clamp this sinusoidal waveform to a new DC level, that is going to be called as clamper. So if I am going to construct negative clamper, my waveform will go downwards, that is your negative clamper. If it is positive means my waveform will be shifted upwards. So by the direction of the diode itself we can say that your waveform is going to be clamped to the positive direction. So this is a negative clamper. We are going to have a function generator, a capacitor, which the capacitor is going to be used for clamping purposes, and your diode